Hello, welcome to Rapid Redis. My name is Scott Gagno. I'm a programmer of 20 some odd years, worked in various languages, Smalltalk, Java, Ruby, Node.js, worked with various backend databases on SQL object and NoSQL platforms. And you can find out a little bit more about me and the projects that I've been working on recently on GitHub. Just look for the Gagno. So, introducing Redis. In this section, we're going to take a look at SQL versus NoSQL, get a little background on what Redis is and where it's coming from. And then we're going to look at some of the features of Redis that lend itself to certain applications. Section 1.1, Introduction. What does this course cover? So in this course, we're going to learn, as I said, a little bit about NoSQL and what Redis is itself and how it works. We're going to learn how to install and run Redis. We're going to learn about storing and retrieving data in Redis using the command line interface and the various data structures that Redis offers to you. And then we're going to create a simple Node.js application that uses Redis as a cache for accessing Twitter queries. So there you have it. We're going to be covering some theory and a lot of application, and I'm so glad you're going to join me. So our next video, we'll get right into it with SQL versus NoSQL. SQL versus NoSQL. So the primary difference between a SQL database and a NoSQL database is actually its structure. A SQL database is known for having a relational structure, and that is predefined schema, a tabular data set, and then it makes relational connections between the data. So what this means is that you have a very structured, organized set of data. It's laid out rather like a spreadsheet would be. And then you have connections between them. Whereas in NoSQL, you have a dynamic schema. In other words, your schema changes or can change. It can be different with every object that you store in the database. You have various data structures that can all exist at the same time in the same data collection. And so it's an unstructured data set. And in fact, you can also have version data. Also, the query language differs between the two. SQL obviously uses the SQL query language and stored procedures to access your data. And it's a very powerful language in letting you access your data in very advanced and very complex ways. Whereas NoSQL, on the other hand, can rely on a custom query language, perhaps an object query language. You can have potentially a SQL-like query language that's a subset of SQL. And sometimes you have no query language at all, and instead it relies on custom code from the client. And then finally, scalability differs in that SQL databases are generally scaled vertically. That is, if you need more capacity, you add more disk space, add more memory, add more processors to the one computer that you're working on. When you look at NoSQL databases, they tend to scale horizontally, so you have a larger and larger cluster of machines that are all communicating to serve as your database. So some examples of SQL you're probably familiar with: Oracle, Postgres, MySQL. Whereas on the NoSQL side, you have a wide range, and just a couple is Redis that we're going to talk about. But you also have things like Cassandra, MongoDB. So these are document or wide column databases. So just to summarize, SQL databases focus on having a well-defined structure and extraordinary ad hoc capabilities, whereas NoSQL databases generally feature much more flexibility in your data structures, horizontal scalability across your network, and special use cases. So in our next video, we're actually going to dive into what is Redis specifically. What is Redis? Well, Redis originally was named after a remote dictionary server, which is basically a remote key value store. As it's grown and become more capable, it now is referred to as a data structure server, and we'll see why that is. But also it's interesting to note that Redis is the most popular key value store, largely because of its simplicity and speed. So a key value store, you've heard this term now. Basically what that means is that all access into the database is through keys. A key is basically just a string that you can use to store a value or retrieve a value from the database. There are no indexes, there's no query language. All access is direct, so you just maintain these keys and look up information that way. All of the data in Redis must exist in memory. This makes it extremely fast because it doesn't have any overhead of network or disk, but it does put some limitations on the size of your data. In addition, you can have a network database. It can be local access or it can be distributed access. You have the ability to replicate your data, and you have the ability to have a cluster of databases that serve your client. And then you have optional durability. And what this means is that you can run the database in a few different modes. One mode is memory only. The data is never written to disk. It is only used in memory, and if there's a crash, there's no recovery. This can be useful in transient cases where maybe you're just using it for a cache and you don't care about the ability to recover. You also have a snapshot mode, the RDB mode, and this is the default mode of Redis, in which periodically the contents of your database are written from memory onto disk, and then you can recover from that point. An append-only file, the AOF, which allows you to have the most reliability by continually writing your data updates into a file so you can recover to within a couple seconds of a crash and continue on. There is also the option for master-slave replication. So in case your primary database server fails, you have a secondary that can be picked up. And finally, Redis is open source, which gives you the ability to go to the developer community as a whole for support. There are also companies that will support you with Redis, but it gives you the ability to audit the source code yourself if you need for security purposes or other purposes. And you can make fixes and even changes. You can fork the database and make a custom database if you wish, because it's all available under the BSD license. So in summary, a couple of key points. Again, Redis is an in-memory key value store with all the trade-offs that come with that. And Redis is laser focused on performance and simplicity. So our next video, we're going to talk about some applications of Redis. Applications of Redis. Some of the differentiating features of Redis that really lend itself to certain applications. As we've said, the blazing fast performance of an in-memory database, the simple access system of a key value store, both have its place. But we also have features like least recently used key eviction and timeout of data. We have sets and sorted sets that allow you to do things like intersect and union and have the capabilities to select a slice of data based on sorting criteria. And then we have a publish subscribe mechanism. All of these in total allow you to use this database especially well for situations where you have session storage, which is largely transient data, caches, also transient, queues, which the pub sub mechanism can take advantage, as well as notifications, and then leaderboards in a game scenario. So in summary, Redis is optimized for a different set of applications than you would use a traditional SQL database for. While traditional database has a very structured organization and is well suited for very complex, advanced ad hoc querying that you might need in an enterprise, Redis instead focuses on particular cases, for example, caching and pub sub, where you need blazing fast performance and simple access patterns. So for our next section, we're going to get started with Redis. Section 2, Getting Started. So in this section, we're going to take a look at how we install and run Redis, and even more importantly, how we can start up the Redis CLI, the command line interface, and start interacting with the database. Installing Redis. So the very simplest way you can install Redis on OS X is if you already have Homebrew installed, it's simply a command brew install Redis. If you don't, you can go to brew.sh and it will tell you all the information that you need to know to install Homebrew. You need to have Ruby installed. And after that, it's a simple matter of running this little Ruby script here that they include on their page. Now, if you don't have Brew or don't want to go down that road on OS X, or you have a Linux system, you can download the source and build it from there. And I can run you through this real quick. So we run wget as they've specified. It downloads the source, extract that, go into that directory and make. And should all go well. There we go. Okay, some notes on that. Obviously, it's pretty easy to use and install there. If you don't have curl, and by default on OS X you do not, which you can also install that using Homebrew if you have that. But otherwise, you can use curl, and I've included the curl command there instead of the wget. But also another note is that you have to have the developer tools installed on OS X, which don't come by default. The developer tools are easily installed, however, if you go through the App Store. Now, Windows is not directly supported by the Redis open source group. However, they do have their own GitHub repo. This is the MS Open Tech Redis repo. And you can look down here just a little bit, and it shows you how to build Redis using Visual Studio. There's one problem that I noticed that I want to point out. This link is not, in fact, valid, but there is a valid link that you can get to here to install Visual Studio. It's visualstudio.com, ENUS products, Visual Studio Express, or you can search using Google, of course. Once you've downloaded that, done the clone from GitHub, and installed Visual Studio, then you can open up the msvs/redis server.sln in Visual Studio and merely build it. So just to summarize, Redis is available on most platforms. It is widely available, probably on whatever it is that you're running. And you can build it yourself from the open source code. And in fact, that's how they encourage you to do so. The next video will be running Redis. Running Redis. So now that you have Redis all installed on your system, we'd like to run it. And the command is as simple as just typing Redis server. As you can see here, we type Redis server, and you get a little banner. It may show the same as mine does, in that you don't have a config file, that you can specify a config file on the command line, as you see here. A couple things to note. You have a default port of 6379. And as I mentioned, that you can specify a config file, and it should be pretty easy to find example config files and set that up, but it's outside of the scope of what we can cover right now. And let's stop this. Now, another thing to note when you're running Redis, by default, is it will create a file in the current directory that you started Redis from called dump.rdb. And that, in fact, is the database. That is all the data from your Redis commands. You can specify this in the config, but by default, you'll just find it in the current directory. Another option, should you wish to not install it on your own box, or you wish to have a provider that's accessible from multiple locations and you aren't running your own server, would be to go to a hosted environment. And there's a couple of hosted environments that are available. One such option is Redis Labs. And as you can see, you can sign up for free. Just click the link, start typing in your name, email. Okay, once you've clicked the link on the email to activate your account, you should see a dashboard like this. And from here, you can create a new Redis database, what they call a new Redis subscription. Very simple. We'll create a free one. Let's call our resource Rapid Redis. And to keep things nice and easy, I will give it a password of Rapid Redis. Activate that. Great. Now we have a new resource called Rapid Redis. Now the status might say pending for a little while. And eventually you get a screen like this with a little checkbox. And then we can click in and get all the information we have about the database, including the endpoint, which is the DNS name that we will use to access the database. And you already know your password. Another option for you is also try.redis.io. Now, try.redis is not really a database host. You won't be able to write an application against it, but it does have a nice little tutorial, a little help system. It lets you try out commands off the command line and lets you play with Redis just a little bit. So in summary, you can install Redis, run it locally, or there are hosted providers of Redis that will do that for you. If you want to have a server in the cloud, you can also install it on your own server. So you have a lot of options here. In our next video, we're actually going to play with the Redis CLI. The Redis CLI. So the easiest way to get started working with Redis is through the CLI, the command line interface. This allows you to play in an interactive manner with Redis. You can issue commands, you can see the results immediately, and the results are automatically stored in your database. To start, it is as simple as typing Redis CLI once you have installed. So there's 3 commands that I want to cover right now, which are just the very basic commands of getting the CLI, playing with the CLI before we start getting into the actual database. Ping, auth, and quit. And let me show you those right now. Now I have a Redis server already running. And so if I do Redis CLI and type ping, it gives me a response of Pong. I have a connection. In this case, I don't have a password on my local Redis server, but I can do quit. Now the other thing I can do is actually connect to the Redis Labs database that I created earlier. So if we come back to our Redis Labs dashboard here, we can see the endpoint, or the host name, is here, and the port is here. So we can come back to our command line here, type in redis-cli-h with the host name that it gives us, -p with the port, hit enter, and we are connected. Now let's try ping. We cannot ping, we need auth. So let's go ahead and put that in. Our password. Okay. Now we can ping. So we are all connected and using Redis. The other thing to see would be to go to redis.io/commands. And on their command page, you can see from here all of the possible commands that you can issue to the Redis server. And we're going to be covering some of these in the following sections. So in summary, you've again seen that Redis can be installed locally or accessed remotely. You've seen how to authenticate your connection. You can use the Redis CLI to test the connection and ensure that it's valid. And you can use it for direct experimentation. And we will do that later. So the next section, data storage and retrieval. Section 3, data storage and retrieval. In this section, we're going to take a look at actually working with the database. We're going to see how you store string keys and values in the database. We're also going to look at how key spaces work. And we're going to look more at how you can use complex keys and some of the basic data structures or complex values in the database. String keys and values. So to start with, a key is no more than a string that you use to store and retrieve values in the database. There are no secondary indexes in the database. So you cannot just query the database for any value that you have as you might do in a SQL database. Instead, you use your string keys to be able to access those values through a simple mechanism of set key and value or get a key. Let's go back to our Redis CLI. Now I want to set a value in the database. I'm going to call it my key and my value. Okay. That means it's actually stored this value in the database. And I can retrieve it by typing merely get my key. And you can see it does return my value. So this was very quick, but in summary, all Redis data access is built on these keys. And the way you work with Redis is to create your own access schemes based on key values. And I'll show you a little bit more about how you can do that in a more complex way later. So the next video, we'll talk about key spaces. Key space. So a key space in Redis is nothing more than a namespace that allows you to use the same keys with different values. You can think of it as a SQL database. A SQL database allows you to have the same tables and same columns in different databases with different values stored in it. It works the same way in Redis. And you have a few commands that you can use to work with these. You can select, which allows you to choose a key space. You have keys, which gives you a list of the keys, and flushdb, which allows you to delete all the keys in a database. So to play with the key spaces a little bit, as you've seen, we have my key stores my value. Now, if I want to select a different key space, now if I issue the same command, I don't have any value stored there. If I want to store a value in my key, and I'm going to call this just my value 2, now I have a key in this key space, and if I go back to my original, I have my original value. So you can see how you can store different values in different key spaces and access them using the same key. The other thing that I mentioned is being able to access all the keys with a key spec, which is basically just a way to scan for a certain key. If I type in keys, it gives me a list of all the keys in that key space. I can set another one. Let's set my key 2, my value, and again, I can show you all the keys that are there. And then the final thing that I want to cover on this is flushdb. It's that simple to remove all keys from your database. So be careful with that one. So in summary, a Redis key space, as I said, is similar to a SQL database. It's just a namespace in which you can store your keys. And you can only access one key space at a time. So you notice that you can't treat them as SQL tables and be able to link them together or access them through some sort of namespace qualifier. So our next video, we're going to talk about more complex keys. Complex keys. So a complex key is nothing more than a compound string. So as I covered in the earlier video, all access into the database is through a key, which is a string. A complex key is nothing more than a compound string that allows you to create a scheme for accessing the data in your database. And some of the commonly used ones would be to use an object type :ID, or even object type :ID :field. And this just gives you a way of separating out the pieces of a key to allow you to have a more organized database. So if I want to do something like set person and give it an ID of 123, and we'll call that Scott. And I want to do set person 234, and we'll call him John. Now you can see that we have these person 123 and person 234. Now you can see how this can be used kind of as a primary key into your database, so that I can do get person 234 and I immediately have John. Now some other things you can do with keys I wanted to talk about really quick is a key can be any string up to 512 megabytes. So that's a lot of data that you can store in a string. Now, although you can do that, it's not a good idea to. You want to keep your keys fairly small because shorter is better performing than longer. The other thing that I wanted to talk about is time to live. All keys in Redis can have an expire. And by specifying the key that you want to expire and the number of seconds before it expires, allows you to have things like a cache that can automatically expire values. So that goes either through the expire command or the TTL command. So in this case, let's look at this. We have person 123 and person 234 as we left them before. But now I want to expire person 123 after a second. Well, as you might guess, now that person is gone. Similarly, I can do expire person 234. Let's give it 10 seconds. Now I can do TTL person 234. He has 6 seconds left to go. And you'll notice after 2 and -2, now it's gone. So look at the keys and he is indeed gone. So in summary, you can construct keys out of pieces and use whatever delimiters you want to try and create an access pattern or access scheme. It almost provides a bit of an index for you. Keys themselves can contain information, as you saw. Each key that we put in the database for the persons gave us 2 bits of information. One was the type of object, and the other was the ID of the object. And this can be expanded as much as you want. And then keys can be set to expire. You can give them a time to live. So our next video, we're going to talk about complex values. Complex values. So we're going to cover just 3 basic data types that Redis supports: the hash, the list, and the set. Let's start off with the hash. So a hash you can think of as key value pairs as well. It's a dictionary, much like Redis itself is, but it's accessed by a top-level key, which is the key that you would have to any object in the Redis database. So you see you have a key that gives you access to a set of key value pairs. So your basic hash commands, they all start with H, and they're similar to the key commands. You have an H set and an H get. Each of those take 2 keys, one which is the Redis key, and then second, which is your dictionary key, your hash key. And then you also have HM set, HM get has multiple values, and an H get all for the key. So let's look at how that looks. We want to do an H set, and we're going to call our dictionary, in this case, let's call it persons. And I want to call number 1 123, and then call him Scott. And we'll do the same 234 John. So you can see this is the same information that we stored before in the key itself, and now we can move it into a dictionary. And now we can do H get persons 123 or H get persons 234. Now we can also do HM set. We can do a multiple set, and we're going to set in persons. I want to say, I'm going to change these around now. I'm going to say 123 is Jill and 234 is Brenda. Now we can do HM get persons HM get persons 1, 2, 3, 2, 3, 4. So now we have Jill and Brenda. And also you can see we do H get all persons. And this actually gets all of the values inside of persons. The next structure I want to talk about is the list. And you can think of this as a linked list. It's very fast at pushing and removing values from the list. On the other hand, it's slower indexed. So you want to be able to use the list as a way to access the ends of the list and not necessarily the ones in the middle if you can avoid it. And the way this works also is it's referenced by key, and you have your consecutive values in that. Your basic commands for dealing with a list, I'll start with L. So L push and L pop, add and remove from the front of the list. R push and R pop remove from the end of the list. L len gives you the length. R range gives you a subset of the list. And L trim allows you to truncate the list. So let's take a look at how we might use a list. First of all, we need to push, let's call our list names, and put my name on there. Let's push another name, John. Now, let's do an R push, names, James. So now we have 3 names in our list. We push 2 on the left and 1 on the right. But let's go ahead and do our range, names, and we want to go from 1 to 3. So this gives us Scott and James. We're 0 based, so I should probably say 0 to 3. Now you can see what happened when we pushed these names on there. We pushed on Scott first, remember, and then we pushed on John, which put it at the front of the list, and then we put James at the end of the list by the R push. Now if I just want to access it like a queue, I can pop from names, and you can guess what will happen next. That's right, we get John because we're doing a L pop. If we do R pop names, we should get James. Okay, now we only have 1 left in our list. So let's go ahead and push them back on. Let's get John back on there and James on there. Now if we do our range, names 0, 3, we have James, John, and Scott. Our len length for our names is indeed 3. And finally, we want to show you the trim. We'll do L trim names, and we're going to say start at 1 and go to 2. Excellent. Now if we look at the list, we have John and Scott because we trimmed 0 James off of the list. And the last one that we're going to be looking at right now is the set. A set is like a list, but it has no duplicates and it's unordered. In other words, it's like a bag of things that you can put these values into. But it does give you some very interesting behavior that you can use, because you can have set operations like intersection and union. For example, if you want to test membership, it allows you to create one set that has the members that you're interested in and another set that is possibly stored on your database, and intersect them and see what is in common between those two things. So common cases for this might be friends lists or tags. So the basic set commands that you'll probably be working with are the sadd, which allows you to add something to a set. S is member, and S members allows you to see if a member is in that set and what members the set has. And then you have union, intersection, and diff. S union, S inter, S diff. So let's see what we can do with a couple of sets. Let's create a set called boys, and we'll put in John, Scott, and let's call somebody Jess. And then let's create some girls, and we'll have Kim, Brenda, and there's a girl called Jess as well. So now if I want to see everybody that's in both of these, we do an S union of boys and girls. We can see that we have Scott, Jess, John, Kim, and Brenda. And you see that Jess is not repeated because it creates a new set which doesn't have duplicates. Now if we do an intersection of boys and girls, you can see that the only one in common between them is, in fact, Jess. And finally, let's do a diff between boys and girls, and you'll see that it has subtracted Jess and left Scott and John. So in summary, you've seen keys and values and how they work together, key spaces and how they track these keys and values in their own namespaces. You've seen how we can create a more complex key structure, and then you've seen hash, set, and list, some of the basic constructs that you have in Redis. So our next section is to actually create a Node.js application using Redis. A Node.js application. So in this section, we're going to take a look at how we have built a simple Twitter query application, how a Redis cache was added to that application, and then we're going to conclude a simple Twitter query app. So first thing you need to do to start looking at this is get the example app that I wrote. You want to ensure that you have get installed and node installed. So you can see get-scm.com is here. You would just go to downloads over here, and it would show you and start the download. And nodejs.org/downloads has several downloads that you can do. Both of these are out of scope to show exactly how you go through the download process and install process, but it's really pretty straightforward. The next thing you need to do is do a clone of the project from GitHub and then run npm install to install the dependencies. So we want to do the git clone rapid Redis. This will actually create a directory called rapid Redis. We go into that and run npm install. And that will install all the dependencies that we need to be able to run this, which, as you can see, is a Redis module and a Twitter module. Now, if you look at the directory structure of what you just downloaded, you're going to see something similar to this. There's only a few files. There's a README file, which gives you some basic information that we're going to cover here anyway. We have a cache, config, index, package.json, and Twitter, and then node modules, which is basically your dependencies. And the quick rundown on this is the index.js is actually what drives the application, reads from the command line, and then runs the query. Twitter.js queries Twitter and then calls cache.js to cache the responses. Cache handles the database cache, the Redis cache, and then config has some config values, and we'll go over all this too. So just to summarize, what we've done here is just set up so that we can talk about this in a minute. But you now should have installed a basic Node.js Redis application, and we should be about ready to run. So our next section is talking about the Redis cache. The Redis cache. So we're going to talk about what the application flow looks like. The first thing we do is we make a request from the terminal to our Node.js application that has a query. That query is checked against the Redis cache. It uses the query itself as the key, remember, because it's simply a string. If that is a hit, if we get a value back from the cache at this point, it would go directly back to the terminal. On the other hand, if it does not, it goes on to Twitter, and we make a query against Twitter. And then the process responds, we get a result from Twitter. We save that value in the cache using the key query, and the value is the result we got from Twitter. And then we return that to the terminal. Okay, so let's take a quick look at cache.js, which is the core of how we're accessing the Redis database. Now, if you look here, the main calls that we have to work with here is this var redis equals require redis. This actually imports the Redis functionality that we're going to be using so that we don't have to make network calls to the Redis database. But basically what it will do is expose the same calls that we would make to Redis using the CLI to the JavaScript. The next thing you notice here is Redis client equals Redis create client, and it gives it some options. We specify the port, the host, and some other options, including possibly auth options, so that we can make our connection to that Redis database. If we go down a little bit, we'll see here Redis client get, which actually issues a get command to the Redis database. And the first parameter to that is query, which actually is the key, and it will return the results in this value here in results. And you'll see that if we get results, then we know to work with them. And then finally, down below, we have this Redis client set X. Now, this is not something that we discussed specifically before, but it's a combination of two commands. It's the same as calling set with the value, and we see we have query is the key, results is the value. And we also get to specify in this a timeout, the TTL. And this just puts them together in one command so that it's atomic instead of two separate commands that could fail independently. And you can see this if you go to Redis.io commands setx, it will show you the details of that command. So in summary, you've seen how the application flow is going to work. And you've seen that the Node Redis module has the same commands as the CLI. In fact, there's a one-to-one translation. If you see the command on the Redis.io/commands document that we looked at before, there will be a corresponding command in the Node Redis. And our next video is going to be actually running the application. Running the application. Okay, so now we're all set to get going. So the final thing we need before we start is to create a Twitter account and a Twitter app. So I'm going to assume that you probably already have a Twitter account. If not, you can just go to Twitter and create one very easily. But once you do, we need to go to apps.twitter.com, sign in, and create an application. So your screen probably looks like this once you've logged in. We want to create a new app, give it a name, description, my website in here, and agree. Create the app, and here we go. So now that you've created your account, we want to take those credentials that Twitter has given you, and we want to copy the API secret and API key back to our configuration. So on here, we're going to go to our key and access tokens. In here we have our consumer key, consumer secret. We need those. And we also want to create an access token. And it should show up. There's your access token and access token secret. Now we're going to set these credentials in config.js, and then we're going to run the command. So I've opened config.js here in my editor, so you can see, and I have already set up for you a place to put your consumer key, your consumer secret, access token, and access token secret. So let's copy and paste that there. We'll paste that there. access token. Okay, those are all set. Now we save the config.js and we are configured. Now, I should mention also that if you are going to use non-local Redis, to go ahead and fill in the host name and port name and the password if you need to at this point, so that you can point to whichever Redis you have set up. For example, if you set up a remote Redis, you'll want to put those values in here now. Okay? And once you've done that, now you can actually run the application. So you can see here we're back in our console window. We have our modules here. Our configuration is set. And then we just want to run node index.js, and let's search for the hashtag Redis and see what we get. Excellent. So we have a result direct from Twitter of this information. It looks like some people are searching for jobs. Let's run it again. This was even quicker. Now we get a result from cache. And for 30 seconds, this cache will remain active because we set it for a TTL of 30. So if we wait a moment, okay, so now let's run it one more time. And we see, again, the result is coming from Twitter. So in summary, congratulations. You've just run your first Redis application and accessed the Twitter API. Our next video is the conclusion. Conclusion. Just to summarize what we've learned here, we've seen how NoSQL and Redis fit into the database world as a solution that can provide more flexibility and perhaps more performance depending on your use cases. We've seen how we can install and access a remote Redis or a local Redis using the Redis CLI. We've learned how to use basic Redis data structures, the hash, the list, and the set, to perform various functions. And we've created a simple Node.js application using Redis as a cache and Twitter as a source of information. At this point, you're probably interested in what else Redis can do. I would recommend looking into some of the advanced data structures that they have. They have sorted sets that I mentioned earlier. There's a facility called a hyperlog log, which allows you to do some interesting things. Publish subscribe, which will let you set up queues and messaging systems. And then scripting. You can actually script the database on the server using Lua. And for more information, the Redis.io website is a fantastic place to start. You can see Redis.io commands. I showed you this before, has all the information on every one of the commands broken down. And you can go into any one of these and it will give you a full breakdown of what that command does and how to use it. The documentation page has an enormous amount of information, including tutorials and frequently asked questions, information on administration, troubleshooting, pretty much everything that you would possibly need to know about Redis there. And finally, if you need help with anything, you can always join the mailing list. There's a Google Groups. There's a channel on Freenode, and you can always follow the Redis newsfeed to find out the latest about Redis on Twitter, which I know you now have an account with. So that's it. I thank you very much for joining me on this, and I hope you have fun with Redis.